Okay, so for this question, we have 2 over 7 to the power of 6 divided by, and then we have 2 over 7 to the power of negative 4 times, right? Because these two brackets next to each other means multiplication, and then 2 over 7 to the power of 2. So we need to remember our exponent laws. When we are multiplying powers with the same base, we want to add the exponents, okay? So when we're multiplying powers with the same base, we add the exponents. So here we're multiplying these powers with the same base. I want to simplify this first. And when we're dividing powers with the same base, we subtract the exponents. So I'm going to simplify 2 over 7 to the power of negative 4 times 2 over 7 to the power of 2. We're simplifying this first. And I'm going to add the exponents together. So I have negative 4 plus 2. Negative 4 plus 2 is equal to negative 2. So I have 2 over 7 to the power of 6 divided by 2 over 7 to the power of negative 2. You can also write it like this, divided by 2 over 7 to the power of negative 2, if it's easier for you to visualize that way. And now I have powers with the same base again. So I'm going to subtract the exponent. So I'm going to do 6 take away negative 2, which will give me 8. So my final answer as a single power would be 2 over 7 to the power of 8. That's the answer as a single power. Okay, for this question, we have 2k to the power of 5 divided by j to the power of 3, and it's all of this to the power of 3. So for this question here, we actually have a power of a power, and we know we need to multiply the exponents, right? So it's everything inside the bracket. It's everything inside this bracket to the power of 3. So don't forget that there's an invisible power of 1 here. So it's 2 to the power of 1 to the power of 3. So 1 times 3 is 3. And then it's k to the power of 5 to the power of 3. Remember, we're multiplying the exponents. 5 times 3 is 15. And don't forget, it's also j to the power of 3 to the power of 3, because this is inside the bracket. So it's everything to the power of 3. So it would be j to the power of 3 times 3 is 9. And I cannot simplify, I can't do k divided by j, but I can simplify this. So I would just simply write 8, because 2 to the power of 3 is equal to 8. 2 times 2 times 2 is 8. K to the power of 15 divided by j to the power of 9. And that's my answer as a single power. Okay, for this next question, what I want to do first is I want to simplify my numerator, and then I want to simplify my denominator. I want to make this simplified. Instead of writing j to the power of 5 divided by j to the power of negative 7, because these powers have the same base, I'm going to simplify it as j to the power of, well, let's see, we're dividing powers with the same base, so I need to subtract the exponents. I'll write it over here, 5 take away negative 7, right? When we're dividing powers with the same base, we subtract the exponents. 5 take away negative 7 will give me 12. And the denominator, I am multiplying powers with the same base. So I have j. When we multiply powers with the same base, we are going to add the exponents. 5 plus 4 is 9. And then we have divided by j to the power of 2 divided by j to the power of 3. I can simplify this right now. I can actually simplify that, right? We're dividing powers with the same base. So this would become j to the power of, when we divide powers with the same base, we subtract. So 2 take away 3 is negative 1. And I can simplify this as well now. I've simplified the numerator and denominator, and now I can actually divide this. What do we do when we are dividing powers with the same base? We subtract the exponents. 12 take away 9 is 3. So I'm left with j to the power of 3 divided by j to the power of negative 1. I can keep going, right? I'm dividing powers with the same base. So I'm going to do what? Subtract the exponents. 3 take away negative 1 is equal to positive 4. So my final answer, simplifying this power and writing as a single power, would be j to the power of 4. Okay, for this next question, I have a lot going on with the numerator. I want to simplify this first because there's nothing to simplify with the denominator because the denominator is already written as a single power. So let's look at our numerator. We have powers of powers. So I have 4 to the power of 1. Don't forget to put that invisible 1 there. All of that is to the power of 3, and I have y to the power of 2 to the power of 3. When we are looking at power of a power, we want to multiply the exponents. So 1 times 3 will give me 3, and then I have y to the power of 2 to the power of 3. 2 times 3 is 6. So I've simplified the first power, and now I have negative 2 to the power of 1, all of that to the power of 2, which will give me negative 2 to the power of 2, and then I have z to the power of 3 to the power of 2, which will give me z to the power of 3 times 2 is 6. Okay, so I'm actually going to simplify my powers that I can actually solve. I know what 4 to the power of 3 is, but let's not forget to write the denominator. We didn't do anything with the denominator. I'm now simply going to do 4 to the power of 3. 4 times 4 times 4 is 64. And then I have y to the power of 6. And then negative 2 times negative 2 is 4. And I have z to the power of 6. So I have 64 times y to the power of 6 times 4 times z to the power of 6. All of this divided by 12 times y to the power of 2 times z to the power of, don't forget that invisible 1. And I'm going to put these in brackets as well. So now I like to group my terms together so I can actually simplify 64 times 4. So let's write this over here, just because I'm running out of space. I can simplify that. 64 times 4 is 256 times y to the power of 6 times z to the power of 6 divided by, I have my 12, my y to the power of 2, and my z to the power of 1. And if you look at this, you can see that you can actually still simplify this. We are dividing powers with the same base. Well, I can simplify 256 over 12. I'm just going to write it in lowest terms rather than putting it as a decimal since it's not a nice clean number. So I'll reduce this to 64 over 3. And then we have y to the power of 6 divided by y to the power of 2. When we're dividing powers with the same base, we subtract the exponent. 6 take away 2 is 4. And then again, same thing, z to the power of 6 divided by z to the power of 1. Don't forget the 1 would be 6 take away 1, which is 5. And this is my answer as a single power simplified. And I've put this in lowest terms. It's an improper fraction. You can turn it into a mixed number if you'd like, but we'll just leave it at that for now.